What is going on, Lucid fans? Welcome back to Financial Journey. So very positive day for Lucid. I want to give you a good breakdown of what the data behind the scenes is all saying. Outside of that, I did get several questions as far as the AMP facility, and especially with the Q4 earnings coming up, and they're going to be talking on a wide range of things, one of which is going to be 2023 targets. It is fair to ask and question, where's the AMP facility? When is phase 2 going to be completed? So I'm going to give you a good breakdown of that. In addition to that, near the end of the video, I'm just going to play out this. So the Winter Enrichment Program 2023, Peter did speak at, and he does talk on a lot of good things that is coming Lucid's way. It might not necessarily be this year, but in coming years, it's going to very much positively benefit Lucid and its investors. So once again, just reiterating the long-term mentality of Lucid and why it's going to do a lot of good things. So I'm going to play that for you as well. Before I get into any of that, make sure you guys hit that thumbs up and subscribe. I always greatly appreciate that. And without any further ado, let's get right to it. So currently up 6.76%. Looking at the intraday chart, very much positive because of a little bit more of a positive sentiment out of China on various different things. And when it comes down to the technicals, the latest round of 13Fs did come down the pipeline. Not any real big players in Lucid, but still it's good to see some new positions in the grand scheme of things. Outside of that, really reduction in buying coming from big players on the secondary market. So I don't know if that's maybe just a little bit more of a telltale sign, because I think a lot of people are very much behind the scenes doubtful of this rally, and I think you can also tell that based on the secondary market. So these are all the transactions today on the secondary market, which is basically what typical retail investors do trade on. And these are all the transactions as well over $100,000. So once again, this is basically what happened on Friday, and is kind of what the normal is. So as you can see, it's very abnormal. So once again, let me know your thoughts on that. I'm just here to list the points. Do you guys interpret that as positive, negatives? I'm not a financial advisor. In addition to that, the options breakdown. So it is for the most part pretty mixed as far as calls being purchased, puts being purchased. And on a side note, if you guys don't know, options highly suggest in researching them, but there was this one very much large one that was a call. So depending if that is positive, negative, just a breakdown of what is bullish, bearish, or neutral. So as you can see, the majority of that call was in fact bullish. So behind the scenes, clearly people might be anticipating a little bit more of an upside potential with Lucid. So again, that could be seen as a very good thing. Looking on the actual chart, attempting to break outside of the lower percentile of the Bollinger Band. So it did fail, unfortunately, because it bounced off of that resistance. But hopefully, if this does continue into this week, outside of the CPI data, depending if that is positive, then that might be enough momentum to kind of get it a little bit higher. Looking at stochastic, very oversold still, so the black line above the red showing a nice bullish sentiment. Momentum number retail investors have been continuously getting in. So once again, behind the scenes, I think fundamentally, Lucid is a very good buying opportunity. Of course, like I always say, these videos are for entertainment purposes only. But when it comes down to the AMP facility and the upcoming Q4 earnings, because they failed to in Q3 give any guidance for 2023, so it is fair to say and question, where's AMP facility? So based on this was the Q3 earnings. They did basically bring up one aspect of the AMPs, is our phase 2 expansion AMP is progressing, and we are expecting to begin to move the air production to the south building in the first half of next year. So that is pretty vague. So within the 6 months, Peter did say most likely, I think it was in the last interview, that it was going to be in either February or March. I think that's also what the rumors are as well, but technically based on earnings, and of course outside of what Lucid does say, is all speculation. So Peter did say it is within the first half of next year. Also based on the Q2 earnings, this is where they did reiterate their overall target. So they did say 90,000 units is going to be accessible once that phase 2 is done, and they do anticipate that by the early part of 2023. So once again, I think that's a very good thing, kind of mirrors exactly what they did say in the Q3. So once again, I think that's pretty good in the grand scheme of things. As far as what that means, so as far as this, it does kind of keep in line with the phase 2. So these are a little bit more older plans. So this is from November of 2021, where they do say, and this is where they're currently at phase 1, 34,000 units for capacity per year. 90,000 per year, and then at full capacity 365,000 units of overall vehicles per year, and that's going to be broken up between the Gravity and Airs, and as well that new vehicle as well, mid-size SUV that's coming out mid-decade. I don't know what they're going to be calling that as of yet, maybe a variation of the Gravity, who knows at this stage in the game, but this is the breakdown and it looks like they are sticking to that. As far as the actual forecast for 2023, this is what everyone wants to know, because as of this, so in November 2021, they did originally have 20,000 for 2022. Of course, we already know that got dropped several times. 49,000 in 2023, 90 in 2024, 135 in 2025, and 251 in 2026. So once again, what are they going to give for future guidance? I think this is what everyone wants to know. Like I said in previous videos, my own interpretation is it has to be at least 30 or greater. Ideally, if they stick to that 49, then amazing stuff. Keep in mind though, based on this, they are currently at 34,000 a year. And if, for instance, argument's sake, they say and come out in June to do this, that means they can do an additional 45, obviously based on the math. So it is fair to say that at full capacity, assuming phase 2 is completed in June as a worst case scenario, then they can do roughly about 80. So the 34 plus the 45. So let me know your thoughts on that. It definitely is more than enough, in my opinion, to satisfy investors. So I think they're being a little bit more conservative with the 49. My own opinion, of course, based on that. So before I actually do get into this breakdown, the WEP 2023, where Peter does talk on, give yourself a shout out in the comments below if you've been buying or what you've been doing, because today I did actually sell some position of Sofi and added it to Lucid, because it might not necessarily be the bottom, but I think in general, after me researching Lucid a little bit more deeper, it kind of reinvigorates the investor in me. It makes me realize that yes, short term does suck on Lucid. I'm not here to say anything other than that, but longer term, that is where Lucid is going to be doing a lot of good things. And in this actual kind of speaking or keynote speaker or whatever it is for Peter, he does talk on a lot of good things, and it kind of does put it in perspective on exactly why we're investing in Lucid in the long term. My apologies in advance, I don't know why I'm apologizing, but for the actual individual who does speak in this, very difficult to hear, so I'm going to try and to adjust the actual audio behind the scenes or after when I edit to make it a little bit better. But once again, at the end of this, let me know your thoughts on this if you've listened to this, because near the tail end of this, it actually is a lot of good questions and it's a little bit more environmental, kind of stepping back. So let me know your thoughts on that. Don't forget to hit that thumbs up and subscribe. I always greatly appreciate that. And with that all fun stuff said, let's get right to it. So I'm just going to take myself off here so you can kind of see that, make it big screen.
Good evening, ladies and gentlemen. May I please have your attention? Our session is about to begin. Good evening to everyone here with us and people online from all over the world. I hope you had a great and inspiring time enjoying the many motivating and engaging talks and events that WEP has to offer. Thank you very much for joining us for the concluding talk of today. My name is 𝗖𝗓𝗡𝗘𝗖𝗧, and I'm a PhD student at 𝗖𝗓𝗡𝗡𝗘𝗖𝗧 Center for Desert Agriculture, working with Professor Rodwing to create rice that can feed the world during climate change. Climate change is a defining issue of our time. From shifting weather patterns that risk food production worldwide to rising sea levels that risk catastrophic flooding, the impacts of climate change are global and unprecedented in scale. Electric vehicles are an important part of the global agenda to counteract climate change. Drastic action is required to combat climate change now, or its impacts will become more costly and numerous in the future. Governments worldwide are actively encouraging the switch to electric cars to combat climate change. I'm very excited today to introduce the CEO and the CTO of Lucid, Mr. Peter Rawlinson. This talk is particularly inspiring and exciting as Lucid is set to build its first electric vehicle assembly plant in Saudi Arabia in King Abdullah Economic City, just 25 minutes away from KAUST. Our talk today will be 1 hour with 15 minutes of Q&A. Please join me in welcoming Professor 𝗖𝗓𝗓𝗪𝗓, the head of Physical Science and Engineering, who will introduce Mr. Peter Rawlinson. Thank you very much.
Thank you very much. Good evening to everyone. I'm sure that everybody here is very excited to attend the talk of this evening. So I know most of you already. My name is 𝗖𝗓𝗓𝗪𝗓, so I am a professor of mechanical engineering here, and I am also the interim dean for the Physical Science and Engineering division. And it's a real pleasure for me to introduce our speaker tonight, Peter Rawlinson. So Peter Rawlinson serves as a Chief Executive Officer and a Chief Technology Officer of Lucid. So as a CEO, he is responsible for all strategic and business aspects of the company. As a CTO, he is responsible for the creation and delivery of all Lucid products, and he brings over 30 years of automotive industry experience to bear in these roles. Prior to Lucid, Peter was Vice President of Vehicle Engineering at Tesla and Chief Engineer of the Model S, where he led the engineering of the Model S from a clean sheet to production readiness while building the engineering team. A graduate from Imperial College, University of London, Peter was formerly head of vehicle engineering at Covers Automotive, chief engineer at Lotus Car, and principal engineer at Jaguar Cars. So with this impressive resume, Peters is going to present a keynote entitled Efficiency, the New Imperative for Electric Vehicles. Welcome, Peter Rawlinson, and the floor is yours for the keynote. Thank you.
Thank you so much, Professor. Thank you so much, 𝗖𝗓𝗓𝗪𝗓. And to all my friends in KAUST, reaching out to you from a wet and rainy Monday morning here in head office at Lucid in Silicon Valley, California, to wherever you are in the world. It's torrential rain outside. We have an atmospheric river going on here, but nothing could stop me getting up bright and early to present this wonderful technology to you all. And today's talk comes with a little health warning, because you may detect that my enthusiasm for the EV and the impact this can have upon the greatest challenge facing mankind today, global warming, is palpable. And it's really like a disease. Once you start driving an EV, you'll never go back. And the health warning to each and every one of you in the engineering faculty of KAUST is that once you start engineering EVs, you'll never go back. So with that said, I'd like to really direct to the main thrust of today's topic, which is efficiency. Why is efficiency so important? Why is this the key, the core tenet of everything we do here at Lucid? Why was nobody talking about efficiency? Well, there was this kind of paradigm, this way of thinking, which was born of the internal combustion engine. That's my theory anyway, that what's the benefit of an efficient combustion engine car, an ICE car? Well, of course, it costs less at the gas pump, it costs less for fuel, and it has a more sustainable environmental footprint, undeniably. But probably in all other ways, the efficient gasoline car is worse. It's less fun to drive, it's less performance, it's about eking out minimal performance, maximum miles per gallon. So there was this perception that electric motors are inherently very efficient. There was nothing that could be gained. There was a commoditized product already. But actually, most electric motors are designed to work in a very narrow operational band. They tend to work pumping stuff, blowing fans, at a very set speed and torque operational range. And so they can be tuned for that level of efficiency. Whereas an electric motor for a car has to operate right through a spectrum, a range, an operational spectrum. And it's a very different demand upon an electric motor. So rather than consider all these systems in the electric car to be commoditized, we took the strategic decision at Lucid to develop them 100% in-house, not just to create state-of-the-art. That wasn't enough. I wanted to advance the state of the possible. It wasn't just enough to be really as good as everyone else. We owe it to this generation and future generations in terms of the impact upon global warming to explore the possible, the art of the possible. How far can we take an electric car? Because the more efficient we can make an electric car, everything gets better, unlike a gasoline car. Because if you can go further with less batteries, remember the battery is the heaviest part of the electric car. It means that we can have a lighter car, more fun to drive, more agile, and that creates a beneficial spiral of yet greater efficiency. It also means that we can have more footroom inside the car, and I'll show you that very shortly. Everything gets better with more efficiency. Strangely, even performance does. Because if there's a set number of electrons that can come out of the battery pack, depending upon the C rate of the pack and its capacity, if you have a more efficient drivetrain, you'll actually deliver more power to the wheels. So paradoxically, you don't get this, to a certain degree, mutual exclusivity between efficiency and performance. You can really have your cake and eat it too. So some of you will maybe be familiar with my tech talks, and so I might cover some ground that you're already familiar with. But at the center of our battery pack are these battery modules, each of which comprises an injection molded unit holding 600 battery cells. We have them linked together with these bus bar connections, which are injection molded, they're over molded, integrally molded into this nylon reinforced plastic, which is fire retardant. And on the end, we have a cooling plate, which cools the cells, which are very simple two-piece plate with these dimples, which act structurally to hold the two clamshells of the cooling plate together, but also they induce turbulent flow, which improves the heat coefficient, heat transfer. And they direct the flow around in a particular flow pattern, which we intensively computer simulated before we ever created this system. And it's super simple, designed for mass manufacture. We have each battery is about 4.2 volts open circuit. So we have, in series, 10 sets of cells here, 30 in parallel each. So this unit, when it's wired up, and there's no cells here at the moment, actually has an open circuit voltage of 42 volts. So if you put 10 of these in series, we get 420 volts. If we put 20, we get 840. And actually, we have 22 in series, which gives us 924 volts for the Grand Touring and Dream editions. And for our Touring, which has just come out, we have 18 of these together in series, which gives 756 volts. So really, really efficient, state-of-the-art battery pack. They're designed for mass manufacture. Now, some of you may also be familiar with the stator of our motor here. And this really has two key, really innovative technologies. Firstly, the way that the copper is wound, it's a wave-wound continuous winding process, a CNC wound process, which is super innovative, which means that we don't have the disruption of laser welds and hot spots. We're looking at reducing the resistance, the heat generated. The enemy of efficiency is heat generation. And right close to these windings, we have these microjets for cooling, right in the very heart, probably difficult to see in this video here. But this means we can extract the heat very close to where it's generated. Now, it's a property of copper, all metals in fact, but particularly so of copper, that as it heats up, its electrical resistance increases. And roughly, I think it's about 0.398% per degree centigrade. So the resistance of the copper will increase about 4% for every 10 degrees. So if you could nip 10 degrees heat out quickly, you get a 4% improvement in terms of energy loss. And therefore, you've got less energy to extract, so you can make the cooling system more refined. So it becomes a benevolent circle here. This is key, extracting the heat very close to where it's generated in the copper windings. Just think 4%. It doesn't sound a lot, but you know, if you've got a car which can do 500 miles range, 4% represents 20 miles range. We're looking for every last drop of efficiency. That's where we go ultra high voltage as well. And inside this core, it's made of literally hundreds of these stampings. The laminations build up, and we can change the pattern of shapes in each of these in order to create a three-dimensional flow through the body of the stator. The possibilities are limitless with this technology. We get the coolant going in this manifold in the center, and it squirts out either end. And we have a little Venturi effect at the end to accelerate the flow, to give a spray effect, just like if you put your finger on a garden hose. And then I want to show you this, which is a masterpiece that we developed in-house. And this is at the core of our inverter. Now, my colleague and chief engineer, 𝗖𝗢𝗡𝗡𝗘𝗖𝗧, will be doing a tech talk very shortly on the inverter. This is something we developed in-house. This is a 6-module silicon carbide chip unit on a cooling plate. This is capable of controlling 700 horsepower of motor power. This is the brain, the controller behind the motor. And there are 6 chips because they're linked in 3 phases, because we have a 3-phase permanent magnet asynchronous motor. So then in the core of the motor, we have the rotor. And if you look at the center of the rotor, the center doesn't really contribute very much in terms of torque, because this is a torque machine. The torque is a function of how far out near the perimeter of the rotor one can achieve that lever arm. So we called out the center of the rotor, and we placed deep inside. This is a tube showing what fits inside the rotor, and we fitted a differential into the motor, a micro differential, which is really innovative. And we've got this new exhibit here, which I haven't shown before, which is an actual assembly of our micro differential, which is in the very core, and you can see how that works. So it can provide differential rotational movement to each of the wheels, front or rear, because we have one of these units in the front and the rear. And we have a single stage epicyclic reduction set on each end, and they're the same ratio, single stage. In the instance of the first set of cars we're producing, the ratio is 7.06 to 1. And I'm actually going to do a tech talk in the next few months when we get a moment, covering not just how the benefits of this system, but just the simple math behind calculating epicyclic gear ratios. And I've thought of an interesting way of an analogy with a bicycle wheel of explaining how to do that, which is very simple math, actually. So I hope you find that as an interesting overview. But what I wanted to do was actually show you a really tangible benefit of having a more efficient system, because we've just started making our touring cars, and I'll take you over to the touring now, and we'll see that we're able to achieve 425 miles range with a smaller battery pack, which gives us more legroom. But first, I want to show you, the front runner of our range. This is the Dream Edition, and I'm so proud because we've just started now selling Dream Editions in the Kingdom of Saudi Arabia. It's begun. And for me, it's really like a home market, because all this has only been made possible. All this technology and this dream has come alive through Lucid's partnership with the Kingdom, and in particular the PIF, the Public Investment Fund, have really made this happen. We would not be here today without that realization of that dream that we're in together. So hats off. Thank you. So this is the Dream Edition, resplendent in its gold. It's called Eureka Gold from California, but I think it's really the definitive color for the sands of Saudi Arabia, surely. Just coming round the back of this car, you'll see just how magnificent it is. This car, in its performance guise, is 1,111 horsepower, and it does 0 to 60 in just 2.4 seconds. And its range guide guys, it has 520 miles range EPA. Now that brings me to the Touring, and this is a beautiful Touring with the 20-inch rims. Just created the last few weeks because we've only been building these cars for the last few weeks, and we've just got a limited number into customers' hands at the end of 2022. But the real headline here is not just that this door opens 90 degrees, but just take a look inside there. There is this footwell deep inside the car, and I'll just get past the cameraman to jump in here to demonstrate. This depth of footwell, this comfort, this ergonomic capability in a car which has got 425 miles EPA range is quite extraordinary. How are we achieving this? No one else can do this because we've got the best efficiency. We can go down to a 93 kilowatt hour battery pack and still get 425 miles range and have all this comfort. So this really reinforces the notion that you know, an efficient electric car is just better in every respect. So here we have Touring and the Dream Edition resplendent in Eureka Gold coming your way very soon. So I'd like to really take this opportunity to move to some of our drive units because it really all comes together. The drive unit comprises 4 key elements here. There's the inverter here at the top, electric motor in the bottom. In the middle, there's a differential, and then there's the 2 reduction gear sets outside. And we actually have a cutaway here. I hope you can see, if the cameraman can come really close, showing the inner workings and explosion of this assembly. And I've actually not shown this publicly before, so this is a first. You see the stator here, and here we see the rotor, see the copper windings, the CNC windings that run through the stator, and then we see the synchronous permanent magnet rotor here, and we're right in the heart. We see the micro differential running out through these spline shafts to the reduction gear set, 1 for each wheel. And there's a bit of a clue here. Look at the size, look at the diameter of these constant velocity joints, splines here. That indicates incredible capability. The motor is capable of 800 Newton meters of torque. It's very, very, very potent indeed. So this whole unit weighs just 74 kilos and yet is rated at up to 670 horsepower. That means that we can get about 9 horsepower per kilogram. Now, really the sort of best that's out there is about 3.5 in the competitive set. Some modern electric cars are getting a lot less than 3 horsepower per kilogram. We're at 9. Now, I want to show you something fascinating, which is very few people have seen, and this brings me on to this, which is the dual rear drive unit for the Sapphire. Sapphire is our performance brand, the ultimate sports sedan, over 1,200 horsepower, which we're launching middle of this year. And already we're achieving 0 to 60 times of 1.89 seconds. It is more accelerative off the line than a Formula One car. It really is. And we're achieving a standing quarter of sub 9 seconds. This machine is really something else. And again, the efficiency counts because given a limited number of electrons from our battery pack, the more you can do with those electrons gives you performance as well as range. So you have this incredibly different paradigm from a gasoline car. We're hugely proud of this unit because it's producing nearly 1340 horsepower from just 148 kilos. Actually, it's slightly better gravimetric weight, power to weight ratio than the single unit because it doesn't have differentials. So we have, it's effectively an electronically controlled differential. But you may say, there's an elephant in the room. We've heard of another machine which is a tri-motor, which has got alien technology and it's got carbon wrap motors and spins at 20,000 RPM. Well, just for, I think as an exclusive for today actually, we have secured one of these units from a competitor, And it's very interesting to see the comparison between this dual motor, which powers the competition tri-motor. This is the rear dual motor, with ours. And it's very interesting to make a power comparison. Now, it is fair to say that this is actually 10 horsepower more powerful than ours, but it's not 10 horsepower more powerful than this. It's actually 10 horsepower more powerful than this, because this is 670 horsepower, our front unit, and this dual rear is 680, and I think it's it's getting on for 100 kilograms heavier. So you've got 680 horsepower here, you've got 1341 here on the Sapphire, and also we're able to achieve the 20,000 RPM without doing the carbon wrapping, because that's the last thing you want to do. You do not want to be doing carbon wrapping. So it's great that we can achieve this performance and the efficiency together, and they're not at odds with each other to a certain degree. In fact, one of the reasons that the Sapphire won't have so much range is not due to the efficiency of the drive unit per se, but it's very much tyre dependent. We see a very great sensitivity of electric vehicle range to tyres, and we've developed special Cup 2 tyres with Michelin for the Sapphire to achieve this incredible performance. And unfortunately, in order to get the grip, even specially designed tyres are relatively energy sapping. So with that, I'd like to just come back to the array of technologies that we have on display here. We designed the whole system super holistically. Battery pack, inverter, motor, differential, rotor, the whole drivetrain. But we also got to look at the efficiency of the car as a whole. That's crucially important as well. One of the reasons we used all aluminum for the car is in order to get the weight down. But if you're a structural engineering student, you might find this fascinating, because even that is very misunderstood. Because if we look at the density of aluminum, it's about a third that of steel. But if we look at the Young's modulus, the E modulus of aluminum, that's also about a third that of steel. So if you look at the specific stiffness, that is the E modulus divided by density of aluminum and steel, it's virtually identical. But scholars of structures will know the classic beam equation, M upon I equals sigma upon Y equals E upon R. And you will know that the R is the radius of deflection, so that's really the big R means that you've got a stiff structure. But there are two moduli there in that formula. There's E and there's I. E is the material modulus, which we're talking about with aluminum versus steel, and I is the shape modulus, the depth of section. And you think, well, if you're designing for stiffness, and we are for the body shell of the car, a lot of it's stiffness because we want the modal performance, we want the modal map and the vibration models to work well. Why does aluminum mean that you get a lighter structure? Because the specific stiffness is the same. And it's because the shape modulus, the I, really comes into its effect, because you can use 3 times the amount of aluminum to create more imaginative I moduli, and that's why you can get typically about a 30–40% weight reduction in aluminum. And actually, that's the explanation why are aircraft made out of aluminum, not steel. That's the answer. It's not E upon density, it's the I modulus coming into play. The other thing that's really important is aerodynamics on an electric car, or any car really, but aerodynamics particularly for electric car. And what we've done with Lucid Air, we've assiduously progressed our aero package. And similar to the E and I moduli, you have 2 key criteria which combine collectively to determine the overall drag on an electric car. You have not just the coefficient of drag, which is the shape modulus, as it were, but you have the overall area, which is the size. So, you have the same shape, but twice the size has got twice the drag, isn't it? or 4 times if it's a linear twice the size. So we've actually been able to achieve, with assiduous attention to detail, the most aerodynamic car that I'm aware of in its class, with a CD of 0.197 now, which is a real landmark. And you combine that CD of 0.197 with a smaller car than the competition, and we're seeing, 10-11% advantage over anything else we're testing in its class. So this is a holistic, big picture approach. It's fascinating. How are we able to do this? Because we've got brilliant engineers who are absolutely passionate about the EV, the role that we can play in addressing this huge challenge to this generation of engineers and scientists, which is global warming, which strikes the very heart of your symposium. None of us can solve all the world's problems, but each of us can contribute in our own area. And the other thing that we do is we do deep and intensive computer simulation. So we try to get the best brains that we can together here at Lucid and give the best computer power, the best computer firepower. And there's something else we also do. We really hardly ever set any targets, because if I'd set a target for a 500-mile car, no one would have believed me when we started making this thing. It was like, the target is as good as we can possibly make it. And so we set, the goal is reach for the stars, and maybe some of you would like to come and reach for the stars and join us at Lucid one day. So with that, I think my time is up. I hope you found it fun and fascinating. You can tell how enthused I am. We've got such an exciting technology roadmap for the future. We're not going to stop. What are we going to do over the next few years? We've got Gravity coming. We've got Sapphire coming. It's a brave new world. Come and join us doing EVs. And with that, I'd like to hand to a short video which will show the impact of Lucid working together with the Kingdom. And then you'll have me for a few more moments to take some questions from the floor. Thank you.
Good. Thank you very much, Peter. Thank you. So we are going to open the floor for Q&A now. So questions for Peter about electric cars. Who wants to start? You have 2 microphones, one here on the left, one on the right. So maybe I will go with the first question. So as a mechanical engineer, I have an echo in the, yeah. As a mechanical engineer, I was fascinated to see some good mechanical engineering from my studies. So there is some words like epicyclic gears and beam theory and so on that I think is going to speak to all the students here. I have a question about the impact of electrical vehicles on the structure, because what I mean, it's absolutely impressive how you have been able to make the power generation unit so compact. But what do you see in the future when it comes to the structure? Today you are using aluminum, but do you foresee the usage of different type of materials, going to composites and everything and so on? So trying to leverage not only the shape effect, the inertia effect, but also the density, the specific density effect and so on. What is your vision for the structure?
Yeah, that's a fascinating. We could talk for days, Gilles. I'd love to think we're going to do carbon fiber. I don't see it coming. I think, strangely, for more affordable cars, smaller cars, I see a hybrid steel-aluminum structure using steel panels in some areas for major stampings like body sides, combining those in a hybridization with aluminum castings, really big castings. We've got some of the largest castings in production today in the Lucid Air. So I strangely see a hybridization between aluminum and steel. But I also see, the impact that we can have with efficiency in reducing battery pack size and with producing miniaturized drive units. Our drive unit today is 74 kilos, which it's 670 horsepower. Just imagine if we could make something with the same gravimetric power density a third of the output for a family car, it would be a shoebox motor. Now, if we had a shoebox motor, we would reduce the incompressible crush length of a car. So we could actually reduce the G-forces and an impact and make the car softer in a pulse and actually save lives in a family car due to that miniaturization. And also the battery pack contributes significantly in Lucid Air. It is a semi-structural pack which contributes very significantly to the overall structural performance of the car, and we should never lose sight of that. I'm not a great proponent of going full structural pack. There are lots of disadvantages with that. I actually looked at that 10 years ago on Model S. I believe I'm a proponent of semi-structural pack, which you get 90% of the benefit and you avoid 90% of the disadvantages.
Yeah. Thank you. So that means, if I hear you, that means there is a wide range of possibilities when it comes to integration of functionalities using multifunctional materials, multifunctional structures, but not going too far because you want to keep modularities and not because I know that people were trying to integrate the structure of the battery pack with the batteries using structural batteries and everything. But as you said, you go to different issues that might be an issue at the end. But there is options going to multifunctional materials yet. There is space for improvement, right?
Yeah, and we use a sort of composites. Even in this battery, we use a high nylon content in the plastic here, and we use also composite structural reinforcements in overmolded in other elements such as the front end module. So the composites do have their place, but I don't believe we're going to see a full composite body structure anytime soon in mass production.
Okay, thank you. So we have one question here. Maybe you can start, please. Yeah.
Hello. Thank you so much, sir, for this amazing presentation. I guess I'm just in complete awe after the beautiful machines that we saw today. One question that I had is, whenever electric vehicles are in a conversation, a lot of people talk about the batteries, especially lithium-ion batteries, and how it's making the same impact on the environment that gas or diesel motors are making. So what do you think on that? And is there a future where we shy away from lithium-ion batteries if they are actually that bad?
Well, I challenge how bad they are. I think that, I mean, we're not talking about nickel cadmium here. We've got a relatively benign metal which is inherently recyclable. We can have an afterlife, a repurposing for those batteries before we talk about recycling. So we're looking at 30, 40-year life cycle for many of these batteries. I also think this is where efficiency comes in, because it's very important that we make the most of the world's precious resources. You know, Lucid Air can do, you know, Grand Touring can do 4.6 miles per kilowatt hour. 4.6 is just over 4.6. Many electric cars can't get half of that, 2.3. So, you know, that means if everyone was driving a Lucid Air, we'd have half the number of lithium ions, lithium mines necessary around the world.
Thank you. Thank you. Please.
Thanks for the talk and the demonstration. I have a question maybe about the future for Lucid in terms of bringing these innovations and efficiency to other medium in transportation, or maybe even beyond. Do you foresee that in the near future, or maybe long term?
Oh, that's a wonderful question. Thank you. I didn't plant this question on you. Thank you. Now, it's very close to my heart. Absolutely. I think eVTOL aircraft are going to be huge. I think there are a whole range of applications, because everyone's looking at, you know, perhaps the wrong axis is like, how can we get more energy in a battery? I mean, that's important, but we're looking at how can we get more energy out of a battery. So if we've got something twice as efficient in the powertrain, in the motor and the drive unit, then we can go the same range as an aircraft with half the batteries. And if you've got half the batteries, you could probably go further. So I think there are wonderful applications in agriculture, in mining, right across many industries, including aircraft.
Thanks.
Thank you. Please, go ahead.
Hello. Thank you so much for such a wonderful presentation, and I'm glad to see the EV industry expanding. And I just had a question about the expected lifetime mileage of Lucid, because usually for normal cars it's about 200,000, I believe. Yeah.
Oh, we haven't got many cars out in the wild that have got that number of miles on them yet. We've been selling them for 15 months. We've tested millions and millions of miles in testing. I anticipate multi hundred thousands of miles. But it's, again, it's very much dependent upon the duty cycle and the use-abuse case. Just as with a gasoline engine, how long does it last? Depends how it's revved. What batteries don't like is too much fast charging. They like to be slowly charged overnight. So again, and they don't like to be topped up too much, and they don't like going too low. So if you stay in that 20 to 80% range of charge, and you tend to do AC overnight, relatively slow charging, and you look after the car, the sky's the limit.
Thank you.
Thank you. Please.
Hi, Peter. Really interesting talk. So one of the concerns that has been recently raised over the large-scale deployment of EVs is the particulate emissions that come out of the tires and brakes, and which seem to have a direct correlation with the weight of the vehicle. And for a given category of vehicles, say SUV, an EV SUV obviously weighs a bit more than the conventional gasoline or diesel SUV. So is there any effort at Lucid being taken currently to address this issue?
I wish we could do everything, probably not as much as we should. We've got great partners with Michelin and with Pirelli. They're both really great. The weight of the car breaks my heart. We're getting close to 2,400 kilograms. And again, that's what I like about the Touring and Pure, that we're able to achieve incredible range with smaller battery packs, and therefore the weight of those cars is coming down considerably. And, this is a topic very close to my heart. I actually think that the EVs of the future will have less range. We need more charging infrastructure to support lower range EVs. And that is important, just as you say, because we want to look at all those particulates. That's a function of the mass. And right now, given the technology, the gravimetric energy density available from the current generation of lithium-ion, I don't see massive breakthroughs over the next 5 years. I see a gradual, a relentless improvement in these metrics. What we need is better infrastructure so we can build next-generation EVs with less range, paradoxically less range, much lighter, and less particulates.
Thank you. So I have a couple of interesting business-related questions online. So the first one is about the power unit, the drive unit. Can you buy it as a standalone, or you have to buy the whole car, or if you want to put it on us? So what is your model now?
I wish we could supply a crate engine like a V8, but we don't. There's quite a lot of integration technology associated with this on the software. I mean, our car really is a giant computer on wheels. We have about 90 computers all linked with an Ethernet ring on the car. And really, this is a high-tech application, which really precludes us providing that option at this stage.
Okay, thank you. And then there is another question that is more about the strategy to handle the global supply chain when it comes to materials specific to electronics or to semiconductors and everything. So I think you work in a business that is very, let's say, dependent on this kind of global supply chain. So how do you handle this as a global company?
Tell me about it, Gilles. I mean, we've got about 250 suppliers right around the world, and we're globally sourced. So there are many challenges to keep ahead and keep on track of all those sourcing challenges. But we have a team of professionals who are really great at the whole supply chain and inbound logistic operation. So hats off to the team in Arizona who are responsible for that.
Thank you. So maybe we have time for the last two questions, please. Go ahead.
Yeah. Thank you for your presentation. In your demonstration, you have showed how much technology and how much you've done in terms of performance. I would like to ask, what about the lifetime of the battery? We know it's not that long. So is there, or where did you reach in this?
Well, we are anticipating a life expectancy of in excess of 10 years, excess of 250,000 miles. We don't fully know yet because all the testing we've done has been accelerated testing. But I'm also a great proponent, as I said, of not just thinking of a two-step process. I think there's an overemphasis, an undue emphasis on going from the application in the car to recycling. I'm a proponent of a repurposing of the battery pack for an afterlife when it's lost a certain percentage of its energy capacity, so its gravimetric energy density has been significantly attenuated, but not so attenuated to render it unuseful as static storage. So I see these units providing static storage maybe 12, 15 years after they've had their life in the car.
Thanks. Last question.
Okay. Thank you for your talk. I have two questions related to the battery. So first is, your batteries are very high voltage and the car is full of electric conductive material. So, God forbid, if someone touched the car, he will be shocked. So what kind of safety, what are you doing to prevent such cases from killing humans, I would say? And the other question is that you said your batteries is made of 10 cells connected in series. So what if one of these cells died out? Will the car still be operational or will stop?
Okay.
Thank you.
Right. So we chose an ultra-high voltage in order to get a great deal of efficiency. It doesn't actually, the high voltage doesn't actually help the rate of charge of the battery. This is one of the world's great myths, because each individual cell just sees 4.2 volts. You know, the reality is that the difference between 900 volt and 400 volt will kill you just as easily. So it's not like we've gone through a threshold that the human body can take 400 volts, but it can't take 900 volts. Both are frankly lethal. So we have to be very careful. One of the things we've done is we break this module down to 42 volts. So this is not connected up, there's no cells in it. But if I were to touch 42 volts, I'm reasonably strong and healthy, I don't think 42 volts is going to kill me. So we put 10 other cells together to make the 42 volts. In this unit, you're quite right. But remember, we put 22 of these in series. So we actually have 220 cells in series. And we have parallel groups of 30 to make the 6600, which will give you the 112 kilowatt hour pack in the case of the GT. Now, you could take that to an extreme. The ultimate would be, 6600 in series, but then you'd only have one per parallel group, and if one cell fails, you lose the whole drive unit. So you could have an ultra-high voltage in theory. If one cell goes, we've got 30 per parallel group. That's actually, you'd lose 1/30th. You'd lose 3% of the power through that particular group. One of the advantages of going lower voltage, when I did Tesla Model S, we went for 75 as a parallel count. It ended up at 74 in production, is that if you lose one cell, you lose just about 1.5%. So it's a trade. How confident are you that you're not going to lose a cell versus how high can you go with the voltage versus the resultant parallel count, P count, for a given overall battery size. We think that 220 series, 30 parallel is a pretty good number, and that's what's powering the car behind me. 220 series, 30p. That's the 6600.
Thank you. Last question, and we are done.
Thank you for your nice presentation. I just have one easy question, could be hard at the same time. How are you going to compete economically against Tesla?
That is a killer question, isn't it? Yeah. So we need to get scale and we need to get margin. And there are 3 steps for a company like us. First, can you make them? 2, can you sell them? And 3, can you make money doing that? And I'm very confident that we have the right product. Well, I think we have the best car in the world. People don't realize just how far ahead this car is. And, you know, can you make money on a car? Well, let me tell you the biggest single cost item in an electric car. It's the battery pack. There is not an equivalent in a gasoline engine car. The gasoline engine doesn't cost anything like the proportion of the car cost that a battery pack can cost. If you look at the cost of, and I'm not going to give our numbers away, but the going rate for lithium-ion cells is around $165 per kilowatt hour in the open market. You can check that out. So if you're really, really good at making a pack, you might, I don't think anyone can, you know, if at that rate, you're not going to make a pack for less than $200 per kilowatt hour. So, you know, if you, and some of these cars you're seeing today, some of the competition, we're talking about 150 kilowatt hour packs out there. Well, you know, at $200 per kilowatt hour, that's going to cost $30,000 to make. Now, we can go further with a smaller pack. We've got about 14% advantage. That means we can actually cut the biggest money item down in cost. If you look at our touring there, we're doing that with 93 kilowatt hours, and we're getting a 425 miles range. The longest range Tesla is about 405, the Model S long range. It's got about 100 kilowatt hour pack. So we've got 7 or 8 kilowatt hours less pack in a car that can go further, and it's more comfortable. So it will cost us less to make that car than the competition. That's how we can compete. We turn this technological edge into a commercial advantage, and that is our core USP as a company.
Thank you very much. Thanks again.